In this study, we're going to look to see if a sedentary lifestyle has changed the body fat composition of men in a company. So what we have data from 1995 showing that men had an average of 22% body fat. And the human resources division of this company is wants to see if that's changed. So they get data on about a dozen guys, and they have this data here in terms of percentage of body fat, and they want to see if this is significantly different than 22% that they had before. So they want to be able to make this conclusion that based on this random sample they've chosen, can they decide that on the average, the whole company, or at least the males in the company, are fatter than they were back in 1995? So what we're going to do is we're going to use a single sample t-test. We have one sample of workers, and we're going to compare that to a population average. We know that the company average used to be 22% for men. So what we're going to do is we're going to follow the instructions that were given in the lectures, and we're going to start off with our hypothesis. And the hypothesis is this is limited to middle-aged men. So the hypothesis was that middle-aged men in this company have more body fat than they did in 1995. And that's going to be 1995. And that's going to be a mean of 22%. And we're going to use, this is our hypothesis is one-tailed. It's directional. We're predicting that they've gone up. So that gives us more power than if we had decided to make a two-tailed hypothesis to say that it was different. So what we do is we have all the data here, and we know the population is 22. It's a little trick to be able to do the one sampled test in Excel is you have to fill up all the cases with 22 for the population, and we're going to do a t-test. So we want to the test we will use. Okay, the test that we're using is a single sample t-test. The data analysis test is going to be a paired two sample t-test of means. And so we're going to actually pair it up with the 22. So it's a little tricky what we're doing here. There's no test and data analysis for the single sample, so we have to use the test that is there, and we do this by filling up this column with the population mean. So we go to data analysis, and we're going to look for the t-test two sample, assuming equal. No, we're going to do the paired two sample for means. So we've got everything paired up with the mean. So the input for the first variable is going to be the whole column plus the title. The variable is just going to be this population the whole time. And the hypothesized mean difference is 0. And there's labels, alpha equals 0.05. The output range, let's click in there, and then we can click here. And that should be good to go. Now let's round numbers off. Whoops. Go to home and then number. And so what are the things that are important? Let's be able to read this. The mean of 25 is important. The n of 12, the observation, that's n. The degrees of freedom are 11. That's going to be 12 minus 1. The t-stat is 1.65, which isn't very high, And the P for the one-tailed test is 0.06. Oh, we just barely missed it. So we're going to have to retain the null because we're using alpha equals 0.05. So how would we write this up? We could write something up. We can say the hypothesis that middle-aged men in this company have more body fat today than in 1995, where the mean space equals 22%, was not supported. The percentage of body fat in a sample, N equals 12, was not significantly different than past measurements. And so the mean that we got here, instead of 22%, was M equals 25.50%, and then T in italics, control I, T, control I, and then parentheses, we put the degrees of freedom, 11 equals 1 space 1.65, comma, P in italics, control I, P, control I, space, equals, space, 0.06, period. And then we put close parentheses. So, oh boy, that was really close. Now, there's a good possibility that if we had taken a larger sample size, if we had chosen more than 12 men, we would have had more power to detect a difference. But because with this small sample size, even though it had gone up from 22% to 25.5%, we can't be sure, 95% sure that that increase would be recognizable in the entire population. So we should do a larger sample size the next time we do this type of study.